So today we're going to be looking at graphing our systems of inequalities. And again, reviewing what systems means, it just means that we have more than one inequality. In this case, we've been working with two equations. And so now we're going to work with two inequalities. So first thing you want to do is you want to get your inequality written in kind of like y equals mx plus b form. So thinking about writing it having your y isolated on the left, and that just makes it easier to graph our lines. The next thing you want to look at is the symbol. Does it include this equal to, or does it not? And in this case, both of them do. And so we're going to see how that applies on our graph. So here we're going to graph this the same way we would graph an equation. So we're going to start with our slope-intercept, and in this case, or our y-intercept, excuse me, and it's -2. So we're going to put a point here, and then we're going to apply our slope, which is +1. So we just get some points here on our graph, and then we'll want to connect them. 1 second. So rulers are definitely going to be your friend, guys, in this case. You're going to want to connect as accurately as possible. And so we're going to have a line like this. Remember, extending it all the way down, okay? And we'll get to what our symbols mean in the graph in a minute. So this is our first line. Now we're going to graph this next one. So it's got a y-intercept of 1, and then the slope is -1. So this one, down 1 over 1, down 1 over 1. We're going to graph these points together, and we'll extend it out. You guys won't have that issue because you will be working on your regular sized paper. This one's a little off. That's okay. Okay, so now let's look at what these are going to have us do. First thing is knowing that if it has this equal sign below it, it's going to include the values for y that are greater than this x minus 2 line. So here was our x minus 2, and well, we won't label it yet, but so we're going to look at this and go, okay, we're going to leave this line solid because it has this equal to in the symbol. We're also going to leave this line solid because this inequality also has that equal to in it. So if it didn't, if let's say this one only was less than that expression, then we would just want to go in and kind of erase to make it a dashed line. But it does have it, so we're going to leave it solid, okay? Now, let's look at the solution. How do we graph a solution to an inequality? We need to shade either above or below our line to indicate that it's all values in that area. So this one is greater than this line. So here was our line with a -2 y-intercept. So here it is here. And we want y values that are greater than this line, okay? So look here, here's our y-axis, which means that we want, let me change the color. We want everything that is greater than this line for y. And one trick that's helpful if you're not sure is look at your y-axis. Look at your y-intercept for the line. You want values that are greater than that for y, so you're going above the line. Okay? Let's look at the other one. This is y is less than this line. Okay, so here was our line, had a y-intercept of 1 and a -1 slope. We want y values that are less than this line. here's our y-intercept. We want values that are less than, okay? So we just kind of follow, like I did with this line, we follow along this line and we make our shading like this. And with the colors, it's nice, we can tell that this is the only section. You can see that we've got 4 sections. This is the only section where the 2 colors overlap. So this means that the solution to this system is this section here. Okay? And when you show that on paper, you're just going to want to shade in this section darker than you would these ones. So just make sure that the section that shows the solution is shaded in the darkest. Doesn't have to be completely bolded and real dark and black, but make sure it stands out as being the solution. So we're going to do a couple more examples, and then you'll do some more practice problems. So here's our next example. We have y is greater than or equal to the line negative x plus 2. And then we have y is less than negative x minus 2. So we're going to start off by graphing these like we did before. This first one has a y-intercept of 2, and the slope is negative 1. Okay, we know, looking ahead now, what this means is that we need to include this line in our solution, so we're going to make it a solid line. And I'm going to just kind of wing this here, not making it perfect. Okay. Now, I don't want to shade yet because I don't want it to interfere with graphing this second line. You can try that out and do it if you want to, but I prefer to get them both there and then do the shading to show the solutions. So this next one is y-intercept of negative 2, and it also has a negative 1 slope. I should be noticing something. If these were just equations, I would know that these were parallel and they would not have a solution. But we're not working with equations. We're working with inequalities that have many solutions. So we need to see what our shading is going to look like. So we're going to connect, again, not being perfect in mind, but you should be precise and use a ruler on your paper, okay? Now, this one does not include the solution. So I really don't want a solid line. So I'm just going to create my dashes here to show that it does not include the points on that line. It's actually less than them, okay? Let's start with the first one again. So first one is greater than this line. Remember, y values are greater than this line, greater than or equal to. The equal to, we put the solid line, but we need to shade greater than, or y values, here's the y's, we need greater than this line. I'm just going to shade this way. And you guys would like to do it, nicer on your paper with your pencil, just shade that area in. Don't spend too much time shading. You don't want to, take 5 times as long to solve these problems, but make it noticeable. Now the y is less than this line, okay? So that means that we're shading this way. Here's our y-axis. We want y values less than this y-intercept. So we're actually going to shade this way. Now, remember, with a system of inequalities, we're looking for where the shaded areas overlap. These shaded areas don't overlap, right? They are going opposite directions, which does mean then that this one has no solution. Now, I want you to think, what would this one or this one, how could we change those to make it to where it does have a solution? And if you're thinking that if we shaded greater than for this, right, if we change this to greater than, we would actually needed to shade up, which means that at this section here, the solutions would overlap and there would be a solution. But because we shaded less than this way and greater than this way, and they are parallel lines, they're never going to overlap. But that's just thinking ahead, thinking of how we could get them to have a solution. That's one way that we could change the expression or the inequality. Now we're not just going to go around changing inequalities, but I'm just saying make the connection between what would a possibility be in a different scenario for these to have a solution, and that's one way that we could do that. So retracing our steps, first thing you want to do is you want to isolate the y and get it into kind of y equals mx plus b form, okay? Then you're going to graph them just like you would an equation in slope-intercept form, but you're going to keep a solid line if it includes the equal sign, and you're going to dash it if it doesn't include it. Then you're going to graph by shading your solution either above your line or below your line, depending on if it's greater than or equal to. Finally, at the end, you'll know the solution for both inequalities when you see the overlapped shaded areas. And you just want to make sure you show that distinctly in your graph, showing that this is the one section that they overlap. And that's it. You don't have to identify it, because really what you're saying when you are shading an area, there's an infinite number of solutions in that area. So there's no way you would actually write that. You're just shading it in to show it. Okay? And that's it. So that's how we identify solutions in a system of inequalities using a graph. And we'll go over also how to, solve our systems by solving for y and getting them into y equals mx plus b form. I say equals because it's not an equation, but that's the first step if they're not already written with the y isolated. Okay? All right, happy learning.